Today we are working on our very last section of Chapter 6. This is factoring difference of squares. It is a very special factoring pattern that shows up pretty often. So, looking at number 1, we've got x squared minus 100. What you'll notice here is that we don't have x squared, then x, then a number. What this means is if we rewrote it, this is x squared plus 0x minus 100. When there's no number other than 1 in front of x squared, we can automatically look at this last term. You're finding two numbers that multiply to get negative 100, but add to get 0. So what's going to happen is they're going to be the exact same number, but different signs. That's the only way you can multiply to get a negative and add to get 0. What times itself gives you 100? Ten. So this is negative 10 and positive 10. So your answer for this would be x minus 10 and x plus 10. Questions? Okay, so looking at number 2. Again, we have something squared minus something that is a perfect square. Does anybody know what a perfect square is? So I guess what we should do is list some perfect squares. What's 1 times 1?
1.
What's 2 times 2?
4.
3 times 3?
9.
4 times 4? 4 times 4 is 16. 5 times 5? 25. 6 times 6? 36. 7 times 7? 49. 8 times 8? 64. 9 times 9? 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. So that's a pretty good list of your perfect squares. Okay, perfect squares means the way you get that answer is a number times itself. So for number 2, because 169 is a perfect square, and so is x squared, and there's a minus sign in between, we can go right into our 2 factors. To get x squared, that's x times x. To get 169, that is 13 times 13. But to get those middle terms to cancel, 1 is plus, 1 is minus. So again, this is a very special factoring pattern. Okay? Let's try another one. Number 3. This is saying that we've got x squared plus 0x plus 36. An issue that we have here is that this tells you that they're going to be the same sign. Is there any way to multiply 2 things together that are the exact same sign and have them add to 0?
6.
But what's 6 plus 6?
12.
12. So that doesn't get a 0. And the issue is because this is a plus sign. So there is actually no solution for this one because it is not factorable. And again, that's because no pair of numbers with the same sign adds to 0. So that's a really important part of this. It has to be a minus sign in between those to follow this pattern. Okay? Now, number 4 follows that pattern because there's a minus sign. This tells you that they are different signs. Now, what times itself gives you negative 36, or gives you 36 with different signs, and adds to get 0.
6.
Yep. So you can go right into this. One is x minus 6, the other is x plus 6.
It doesn't matter which.
It doesn't matter if the plus is first or the minus is first, as long as one of them is an x plus 6 and the other is an x minus 6, it doesn't matter which one goes first. Okay? Now, what if we have a number in front as well? Ask yourself, is this a perfect square as well? Both of these are perfect squares. And there's a minus sign in between. And it's missing that middle term, meaning there's just a first and a last term, there's no middle term. Any idea what would go in these parentheses? What times itself gives you 9x to the second? Yeah, 3x is going to go in the first part of both. What times itself gives you 25? 5. 1's plus, 1's minus. If you have the exact same thing in parentheses but a different middle sign, it means your middle term is going to cancel. That's a special relationship called conjugate pairs. Last question. Any idea how we would factor this one?
You got 11 or something.
11x. What about the second part?
1 or 0?
Look what's in that second part. How do you get y to the second?
Or just be y?
One's a plus, one's a minus. That's your answer.